Yeah, so hi, welcome to new live stream. Here we're going to take a look at. I'm basically just going to sit and do some coding of the YOLOv8 model. So we're going to look at like how can we set up a tracker. So I've set up a tracker right now that works with the new YOLOv8 model. We'll go into Google Colab and see how we can actually like train these models. We can try to like do some custom models, export them, and try to implement it here in our own Python script. But we actually have this sorted here working. So basically, the new file structure that we can use. I'm basically just going to explain it, and then I'm going to sit here and code, and you guys can ask questions in the chat if you want to. But basically, we have this detection predicted class which we set up, and then here in front this base predictor class. So this is basically like the new structure from this YOLOv8 format. It is really easy to play around with. Then we can actually just use the exact same results that they have. We can just use the detection predicted class as we have down here. We have like the get annotator, the processor, like the preprocessor, post-processing, write results, and all those different kind of things. So this is basically like the same things. And then we can also set up the track function down here at the bottom while we're actually like writing the results. So hey. So then we're basically just writing out the results. We can set up our tracker in the same like this. So here we basically just have our track function. We have our detection, so we have our detections on DET. We take it to the CPU, so this is basically the detections that we just get out up here at the top as well. So again, we're basically just using the exact same things as in the predict file from the YOLOv8 model. Then we just run through all the tracks. We store all the tracks so we can actually like track around the object in the scene. And then we can basically create or initialize our tracker up here at the top, and the top of this code we can also have another file where we just like import it into this script. But again, we basically just have to like play around with this detection predicted class, because this is when we're actually like running the YOLOv8 model. It will run this detection predicted class, and then we can just do all of our stuff inside of this. We can import like our own code, our own module, our own classes, and all those different kind of things. Store the outputs here, write it to a file, do some other different kind of like processing if you were to implement it in your own project. So I'm basically just looking at this in this live coding session, and then I'm going to go into the Google Colab notebooks, try to train our own YOLOv8 models on the dataset that were labeled and used in some of the previous videos on my channel. And then yeah, I'm basically just going to sit here and play around with it. And just make some code. I'm going to create videos about these different kind of things. I'm going to create a video about the tracker, and also just how we can train our own YOLOv8 models, both for object detection but also segmentation. So I basically have the tracker running here. We can run a bit later here on the live stream. But basically here I'll just go into the Google Colab and see if we can actually like set up the training. So here I'm just going to open the Colab and see how we can do. We might even go into like RoboFlow's GitHub as well. So they have some notebooks as well that we can use for actually training. So to have the notebooks here, we can see you have YOLOv8, PyTorch object detection, PyTorch instant segmentation, and also classification. So here I'll just open these in Google Colab and see how they actually work. We can both do it for object detection and instant segmentation, try to train our own models. I'll just go into YOLOv8's website as well. So we can open up our data sets. So I have already labeled data sets on my channel here. So I'm just going to use those and try to train the new YOLOv8 model on those data sets. I also have a course with the YOLOv8 model. We can try to like train a YOLOv8 model, try to implement it and do inference, deploy the model as we did in that course. And then also with the new method here that is provided by YOLOv8. So we have our cop detection, I think cop detection v2. So I think we're going to use the cop detection v2. Yeah, here we have 6 classes. And then we can basically just go in here and export the dataset. So here we have a pretty good dataset. We can basically just go in here and export it. YOLOv8 PyTorch, they already have YOLOv8 as well, so we can just directly go in, export it, show the downloadable code. So basically, let's just run this. So let's just connect to runtime, change runtime. We're in GPU, so let's just connect to the runtime and then just run the YOLOv code while we're actually running through it and see how it works. So to have something install YOLOv8, we have done that. The command line interface basics, already know that. Inference with pre-trained Cogga model, that we basically did that in the last video. We have RoboFlow Universe. If you don't want have your own data set, you can use RoboFlow Universe. We can prepare a custom dataset. I just showed you that in RoboFlow. We can do custom training, validation of the custom model, and inference with the custom model. And then at the end, we can also export and try to use it in our own application and project inside of Python. So we just take the model here from the Google Colab notebook, and then we use it in our own program. Because most of the videos I actually see about YOLOv8, they don't really export the model and show how you can actually use it in Python in your own application and so on project. And so here we're basically just in the content directory. Install YOLOv8. So we pip install Ultralytics. Yeah, this is basically the only thing that we need to do. So here I'm just going to run it. We have done this in the previous videos. I already also did it in the last live coding session, where we talked about how to set it up for live inference on our own computer. We went over the accuracy, compared it to the other versions of YOLO. And then in this live coding session, I'm going to set it up with the tracker I just showed you. I'll create videos about all of it and upload it in the upcoming days. But now we're actually just going to see if we can train our own custom YOLO models on custom dataset. So we have command line basics. We have these detection, task, segmentation, classification, the different modes. I'll actually just go in here and create my own Google Colab notebook where we just basically clean up. We basically just clean up the things that we don't need. I prefer to have that. So let's just go up here at the top. So here, also here we're actually inside the instant segmentation. Let's go for the custom object detection to start with. I also have a dataset labeled with instant segmentation, so I'm definitely going to do that as well. Here I'm just going to zoom a bit out so I can see what's going on. So basically I'll just take this one. Then we're going to have text. Run this block of code, and then we basically just go down. Here we're going to see that we're actually utilizing the GPU. So yeah, we can do that. We can set that up. And then the code here. So import OS, we just go to the home directory, just print the home directory. So we pretty much already have that. We don't really need that. So here we're just going to pip install Ultralytics. And then let's just have all the imports. Let's just have all the inputs, imports in the same one. So here we just already import display, so we can delete from import display. So we'll have to like copy paste this up at above here. Or yeah, basically we don't need this one. Import OS. Let's just import it to be 100% sure. Command line basics. We already have that. We don't really need that here. So here we're just going to call this install. YOLOv8. Going to run it. Here we're going to have another code block. Inference with pre-trained. So we can try to do that to start with. Just see if we can, like, preparing a custom data set, row flow, annotate. We have all these different like things. We have exporting our data set. Then we have the data set here. We can just specify the dataset dot location. So let's actually just do that to start with. Maybe we can just run this inference to start with. So we'll see if we can, if we're actually able to run it. We can see into our home directory. We are already in our home directory. But here we can just have some text. Inference example with pre-trained YOLOv8 model. Copy paste it. We just run these blocks of code. I think we can do that. Here we just need to disconnect from the real run, from the real runtime. Disconnect and delete runtime. Then should be able to connect over here. Change runtime, GPU, go reconnect to runtime. Pip install Ultralytics. Go down, do inference. Here we show it. So after we're done inference, we're basically just going to show the image with PLL. Do we have that? Okay, so here we have ipython.display, then we have image. Runtime must be newly installed. Let's just see if we have it over here to the left. So yeah, let's just try to run it here from Ultralytics, import YOLO. Function does not have no attribute, clear output display. Oh, that's because we haven't imported the whole one of here. So we should do it like this. Could also just have like, so import, we already like import display up here, but it is from display. So probably like this is a module and then we have a function inside of that. But now we're able to run it. We can see some information about it as well. Ultralytics version 8.0.5. We have CUDA 0, Tesla T4, 2 CPUs, 13 gigabytes of RAM. It's pretty good. Let's just try to see if we can run inference on this image here from one of the examples from RoboFlow. It's basically just downloading a model here to start with. And then we have the result saved and runs, detect, predict, and then we have the doc JPEG. Let's just see if we can see. Yeah, so now we get the visualization here. We can also like try with one of our own images. We can even see the car here in the background. It is a really good prediction. But now this is just to show an example of how we can do inference with a pre-trained model here in Google Colab. So now let's go to the fun part. I'm basically just going to have the text here, train YOLOv8 model on custom dataset. Then we're going to have the code. We go down, then we basically just use RoboFlow as we've been doing in all the other different kind of like. So here to have preparing a custom dataset, I already have that on my RoboFlow. I have labeled it. But then we can basically just go down here, pip install RoboFlow and set up our project. So then I'll actually just go in here and copy paste it. So show downloadable code. Basically just zip the files and show the code. And then we can copy it, paste it into our notebook here. So here I'm just going to copy paste this. And we go back to the notebook. We just replace this one here. And then we'll have our dataset stored here. And I'll have my API key here. So I'll just scroll down to the bottom. So this is basically just we import RoboFlow, we set our dataset, then we have our dataset. We can then scroll down to the bottom here. And then we can just directly run the training on our dataset. Because when we run this block of code, I'll just run it. Then we can just go down to another block of code. Let's just add a couple of blocks here. So we have those for later use. So now we have this cop detection version 2.3. We have our dataset, then we can basically just call our dataset.location because now we have unzipped the dataset over here to the left. We have our test train and validation. Again, if you don't know like how to use RoboFlow, you can just go in and watch my other videos about that. So it's now going to run the actual detection. So we have our task. We want to do detection. We want to train. So this is the mode. We have the YOLOv8. So we're going to use a small model, dataset location, dash like slash dataset JAML. So this will be this file here that we want to import. Let's just take a look at it. So we have the different kind of like classes, and then we also have the path, our image path to the test set, train set, and the validation set. So now we have everything. We can basically just go down here. We have number of epochs. We also have the image size. So I need to change the image size here. So let's scroll down to the bottom. We have 640 by 640. So we're going to change that. And epochs, let's just run it for 10 epochs to see how it actually trains. It should be able to do it in 10 epochs. I'm not sure, but it's not really that hard of a task. So just run it and see if we actually get some training results. So first of all, down the model, we can see a summary of the model with some convolutional layers, upsampling, concatenation, and all those different things. We can see the optimizer training. So we have 330 images for training. We got an error here. Probably not. It looks like it's something with the bounding boxes. We didn't get it for like the second epoch, so yeah. Looks like it runs. So here we have the images. We have the instances. We have the bounding box like losses. We have the mean average position. So here we can see like the mean average position already went up like significantly from the first epoch to the second epoch. And here we can see we're already at like 0.62 mean average position of 50 here when we're looking at the average position intersection over union. We also have this 50 to 95 in mean average position intervals from 50 to 95, where we just increment by 5, and then we still have a pretty good average mean average position. If you're just going to the YOLOv8 here or like YOLOv8, then we can see results. So the mean average position of 50 to 95 is around 45 for the small model. So if you just get like anything like we're probably going to get better results with that if we just train it for enough epochs, because we basically have a really simple data set where this is trained on a Coca data set and still achieve really high accuracy. So it needs to be more generalized. Let's go back here again. Let's see. Yeah, so here we can see we already get like pretty good accuracy. We get 80% on the mean average position 50 and around 0.40 on the other one. Yeah, so now we have basically trained for 10 epochs. We get pretty decent results here. We could probably like train it for longer. We can play around with the high parameters of the training. Here you can see we're using STD for the optimizer. We can also see that we have done the validation. So now we're actually just trained the model. Let's just see how it works. We should be able to display here the confusion matrix. So let's just run this. Oops. So home directory is just like content. Should be, and then our resolution or width is just the width of the confusion matrix. No such file. Maybe we need like a slash in front of the content. There we go. So we actually get some pretty nice results here. We can see that we also want to predict background. So I'm not sure why it wants to predict that, but we get some errors with the Halloween cop and just the standard cop in this example. This is actually some pretty nice results for the other classes here. I'm not sure what goes wrong here because it does actually detect the cop here accurately. It looked like it has some problems with so here we predict like hand-painted cup a couple of times, we predict Halloween cup a couple of times. So it has some problems with the Halloween cup here and also just with the standard cup. But again, like the standard cup here was unrepresented in our data set, so that might be an explanation for that. Also, we only trained it for 10 epochs. It took like 30 seconds or something like that. We can also display the results. So all these graphs here will actually be over to the left. So if we go inside the left here, we have the runs, we have the detection. We can both run like the prediction and also the train. But if we go inside the train, we'll have all these images. So we can open up the confusion matrix. You can just right click here and download it to your own computer. And then you'll get the exact same results over here to the right as I just showed you. So we're basically just like scaling the width. And you can also see like the results in the PNG and all those different kind of things. So these are the losses that we're just going to plot now, but I'll just copy paste this content. You need to like specify the directory for your training and all those different kind of things. Here we just scroll a bit down. We can see the loss. So we can see that the box loss is still decreasing, hasn't really like fully converged yet. But we can see the metrics for both the precision and also the recall. We have the mean errors position. It kind of like stabilizes here around 0.8, and maybe we have some errors in our data set. It could have been trained for more epochs, and we probably still be able to like increase the mean errors position. Also, it's still flickering a lot here for the 50 to 95. And we can also show the predictions from our validation set. Here and here. Oops. Let me copy paste this. And then we have our content. No such file. So we have detect. Oh, we haven't run the detector yet. So how does it work inside of this? So inside detect train, and then we basically just have like a validation image. I'm not sure where to have that from. I would think that we need to run this validation first on our validation images, and then it will store the images. So instead of showing the results here, let's just run the inference. So we'll just delete this. So we'll just go out here, delete this, copy paste it here, and then we have our content. Runs the best model, and then we have our validation. We set the mode to validation, we run the flow of code, and we shouldn't get any errors. Basically by just passing all the images through. So now we're done with our inference. If you just go inside this now, we have this validation, we have the different kind of like outputs. And then we can now do inference with our custom model. So we will copy paste this, run it. It would not run because we have this home directory. I need to set it to content. Yeah, so you're asking how I learned machine learning. So basically, I got into machine learning. I actually create these YouTube videos. I started with computer vision. I got into it from university a couple of years ago, and then I basically just got caught by machine learning, how to use like deep learning, machine learning together with computer vision, and combine all these different kind of things. It's just cool that we can take some data, throw it into a model, and then it basically just learns all these different kind of things, and also just the new things about like ChatGPT, just being able to do predictions on images as with these YOLO models, other machine learning models for doing like translation, prediction on different kind of like time series data and so on. It's just really cool what we can do with machine learning, and it caught me. I started doing these YouTube videos, and I just got way more excited about it. Now I'm doing like research within machine learning, deep learning, and all those different kind of things. Just working on it in general, and then it's just really cool. It's just really cool. So that's basically how I got into machine learning. And then I basically just like research new ideas for YouTube videos. I got into like the theory behind it, and then I basically just spent time on it. So I learned machine learning by actually like spending time on it and just doing things. You need to learn like the basics of it. You need to learn like the math behind it and all those different kind of things. And then it's basically just like put time into it, and then you'll be good at it. So now we can see that we run our predictions. We can see we've passed our images through it. So we have predict 1, we have predict 2. So this was our first prediction just on the inference. So now we can get the prediction 2, and now we should get the images here. Yeah, I'll just make this a bit larger. So now we actually get all the images here in our predictions. When we run it in predict mode, it will then actually show the bounding boxes around the objects that we have detected. So now we can see we detect the coggy cop. Again, we get a little bit lower error here, or like a bit lower accuracy and confidence score on our standard cop here. We have the hand painted cup, really high accuracy. It looks like it's 90s. We have the Halloween cup and the white cup. So this is actually like pretty nice predictions. You can go to some of the other ones. Again, low confidence score on the standard cup. It was also underrepresented in the data set. So you can use the YOLOv8 for that. We can just go inside here. We have the health data set check, and then we can see like the standard cup. Oh, so we have this cup here. So I actually have a redundant cup somehow in my data set here, which could actually be causing some problems, or is actually causing some problems. So this is also one of the nice tools about YOLOv8 is that we can use this class balance tool to see how our data is distributed in our data set. So then we just have the standard cup here, which is underrepresented, so it doesn't really get as high accuracy as we would expect. We also get the overview here, or like from our data set. Generate. Already trained the models. So here we have mean average precision of 84, so it's kind of the same as I got on my side. So I'll just call it YOLO custom training. Here we get some nice results again. So this is basically a pretty good object detector. We can just export it, download the weights of our network, run it in our own Python script, run it together with the new file structure and the files provided by YOLOv8 as well. So we can do it in different ways. We can also export it to the ONNX format, run it with the ONNX format, and all those different things. Okay, so now we have trained the model on our custom data set. just going to close all these. We can actually just run this block code to show all the images. Didn't really display that. Just cut this all. Deploy the model on RoboFlow. Then you can either deploy the model on RoboFlow. Yeah, so I'm not going to do that. I'll just deploy it on my own system, download the weights, and implement it. Yeah, so basically you're asking, hey, what's the agenda? So basically I'm just looking at doing custom object detection on the YOLOv8 model. So I previously just made a video about how we can do live inference. Right now I'm just training a custom object detector with some of the different kind of like data sets that we have that we're labeled with RoboFlow. I've set up a tracker as well, so I've basically just used the files provided by YOLOv8, the standard ones, where we have this new kind of file structure. We need to run it like from the command line, and then we basically just pass in the arguments with the models that we want to run inference with, and then we can then we can basically just modify. We can modify the files. We can set up a tracker, and then we actually just set up a tracker as we've been doing with the YOLOv7 and the YOLOv5 model. I have videos about that. So it's basically just combining those things. So here I'm basically just going to, we have the train here, we just trained a single model. Maybe I should go in and see if I can actually create a better data or delete this. Let's just use this model. So we have the best model here that was trained. Maybe we should just train it for more epochs and use the best model just before we export and actually use it in our own Python script. So I'll just do that. So we have detect. Here we have that training function. So just run it for 30 epochs. Let's see if we can get some better results, and then I'll export the model, import it in our own Python script, and then we can try to set up the instance segmentation. So here I'm just running through all of it. So let's create a new file here, new notebook. And then I'll use the instance segmentation. Again, we'll just clean up the code here from RoboFlow. So we have YOLOv8. Custom instance segmentation, long title. So first of all, we'll just check here for the runtime. We'll change the runtime, but let's just set up the code first because we're already using the GPU in the other notebook. Import OS. Need to pip install Ultralytics. We'll just do it here, and then we copy paste these ones, and we copy paste these ones. There we go. And if we basically just have to do the exact same thing as we did in the last video, but right now we just change the task here to segmentation. We can write the text afterwards for the headlines. So we can set all these different kind of parameters. We can go in and check the parameters. Let me just actually go inside and see if I can find all the parameters that we can set. So we have the arc here on the next format. Exact the same as the example above, arguments. So here we can see all the arguments that we can set. So for training, we can set all these arguments here to the function directly when we run the program. So that's really nice if we just directly want to change the learning rate, for example, or the optimizer. We can also use the atom optimizer that uses STD as a standard. We can see all the default values. Yeah, so right now I'm trying to do segmentation. I'll try to do segmentation on a custom data set. I just did object detection. I'll download the models and then deploy it in my own Python script, just to see how it works. So all the videos I've seen on YouTube right now is basically just using these notebooks here to train on a custom data set, do inference with the YOLO model, but they're not really showing like how to download it, how to actually use it in your own Python code. So I'm going to do that with object detection and segmentation, and then I'm also like creating a tracker on top of that. Yeah. So I'll create individual videos for all these parts that we go through right now in the live. Epoch 15, we can see that the precision has increased a bit. Maybe the reason why we don't get like higher accuracy and or like higher precision is probably because we have this two redundant cup class, which will cause some errors probably in the network. Yeah, so we're going to run this. We have to do that one. We have prediction, the results, Python SDK. Yeah, so this is basically how you would doing it if you do it in your own Python script. So I'm going to show you that later on. Let's just choose the source, and we'll choose and then here in the predict function, we can set all the parameters as we do in the command line as well. So if you don't want to like run it from a command line, you want to run it from a Python script, you can do it in this way. So basically just set up the YOLO model, the path to the model, and then we have the source. We can also just set it to 0 if we want to use our webcam. Set up the confidence score. We can show the labels and all those different kind of things. So these arguments to this predict function will be the exact same ones as in their documentation. So we can set all these ones, but we have the prediction, so we call it a predict function. We can also call the train function if we want to do the training. But the YOLO, like the YOLO command we run, is basically doing the same. So for prediction, we can call the show, save text, save confidence score, hide labels, hide confidence score, and do some other different kind of things. Preparing a custom data set. We were doing that in the other one as well. So then we'll basically just copy paste this one. And then we need to actually do download YOLOv8. So just need to make sure how we can actually do the instance segmentation, in what format we need to do it, because I already have that. So we have the projects, we have the cup segmentation. So this is a semantic segmentation, but maybe I can export it. So we have data set here. Let's see if I can export it as in the correct format. So here we have the Coco segmentation, semantic segmentation, masks. I'm not sure we have to do it. I think we need it in the YOLO format, so we do need to do like instance segmentation. I might have an instance segmentation in here. So we have cup segmentation, we have instance segmentation here. Let's go in and see if we have other export options. So here, yeah, we can see here now we have YOLOv8 for instance segmentation, show downloadable code. This should be the code that we need. So now our model is done training. We get a bit rare results. Again, I'm not sure why it does the background here at the end. Oops. Is it already done training? Train 30 epochs. Yeah, we're at 30 epochs now. Where can we find the dataset? So basically, you can go inside my our RoboFlow here, you should be able to find the datasets in here. Or you can go to RoboFlow, you can go into the universe, and you can find whatever dataset you want. So you can basically just go in here. I want to do object detection, and then you'll basically just get some datasets here. You can just directly import and export the code for. So let's see, if we want to do food detection. You just go inside this one, download this dataset, and then you'll basically download your dataset. You either upload it or you just create it with RoboFlow, export it, and then just copy paste the line of code that I just did. Here you can choose the popular download formats, YOLOv8, show downloadable code, continue. It will zip the files, and then you can basically just copy paste the code as I just did. Let's just finish this here with the instance segmentation. So we have segment, custom training. We need to copy paste that. So now we have our data set. We do the actual the training. Scroll down. We show an example, an image example with the confusion matrix. Here instead of home, just have content. Show the training results. I'm not sure why we don't get these images, but we're just going to validate the model. Validate the model, specify the content. Inference, and now we do validation, now we do prediction. Content, code. Try to see if we can display the images. Or else they will be in the folder over to the left. So it will be inside here. When we actually run it, so we have segment predict 3, predict, that will be predict. Okay, so that's why it wasn't working on the other one in here. So let's actually just copy paste this, go in here and see if we can do it. So it was after the training. Now we have done the validation. Thank you. So we go inside here, we have content, we have runs. Inside runs, we should have, instead of segment, we have detect, and then we went with predict 3. Let's just go with predict 3. And here we can basically visualize it as well inside the notebook. So before I didn't specify this predict 3, I was just specifying predict, and we didn't really do anything with that. So now we have updated to that as well. Here we have segment predict 1, so that will just be predict if we just run it for the first example. And then yeah, that should be it. So after we validated model here, we can basically just go in, download it. So our training is done in here. We can see like our train. We go inside our train. I'll just delete this one here because we should actually have everything now in our own notebooks. Just go inside. We have to train. So we have to run, detect, predict, train 2. So we have to train 2 here. We have the weights, and then we're going to download the best weights while actually training the model. And this is our custom object detection. So here we're just going to download this model here. So we have the object detection, custom object detection on these cops, and then we're going to train it on the instance segmentation. Then we can export that instance segmentation as well, try to implement it in Python. And then we basically have live inference with our own custom object detection with YOLOv8, instance segmentation with YOLOv8, and then I also created a tracker on top of that, so we can actually track objects around in the scene. So here I'm just going to show it in the folder. I'm just going to rename it over here to the left. So this is our cop object detector. cop detector. Cop detector. I'll open the code here. I'm just going to run it inside. Let me just see the file structure here. I'm basically just going to. I will actually just create a new folder here, so I'll just go inside. Here I'll have custom YOLO models, and then I'll just throw it over here. And now we can go in and train it. So now let's go to YOLOv8 custom instant segmentation. So now we can go in, change the runtime. We want to use the GPU, save, manage session. We'll terminate the other session for the custom object detection. We also have this one here. We don't want that, so we're going to terminate that. And we're going to terminate the object detection. Now we only have the instant segmentation running. I'll just zoom in here a bit. Let's add the text as well. So YOLOv8 custom train YOLOv8 for custom instance segmentation. Then first of all, we need to install text. Then we have the example here. We show the example, import the data set. Import data set from Overflow. Train the YOLOv8 model. Have segmentation, restore results, we do validation, prediction. Here we go, we visualize the results. Let's just run these blocks of code and see if we can actually train our model. Pip install into analytics, which will contain the YOLOv8 model. Import the modules. Task segmentation model predict. So here we're just going to use a pre-trained one for segmentation, confidence score, and example. We'll run it, run it, run it. So here we're just basically just going to see the results. So again, this is a pretty nice detection. Like we can filter it even more with our confidence score, but like if we filter it more, we can see that we're not really segmenting out the dog here, also the person. But again, we're only using like a small model. Let's just try here for for fun to use like a larger model. So let's just use the large model here and see if we can get better results. Let's set the confidence score to 40. I'll just run it here again and see the results. Now we need to download the new model. I didn't really set the confidence score correctly, or should have filled it out those things less than the confidence score. It didn't really seem to do much to this image. Let's try it with X large. Let's just try it out. And I'll just change it back to the small model here again afterwards. Oh, I made a mistake. So here we have the runs segment. Now we've downloaded the models. We have the runs. We have segment. Then we have predict 2. So this was the with the large model. So it's just run that first. So we have predict 2. We have the doc. And now we visualize the results. So yeah, again here we just see like we just changed from the small model to the large model, and now we get a way better results. We get the backpack here. We get some really nice detections here of the backpack here. We have I'm not sure what this is, but if it's part of the backpack or something like that. We have the cover here to right. We have the dog. Way better segmentation of the dog compared to the other one. So just by changing the model, we just get way higher accuracy. But again, it will be harder to run in real time. I'll try to run in real time on my own computer, on my own system, and create YouTube videos about that. Also have the person, pretty nice segmentation around that as well. We have the X large model here. Let's solely see the predictions for that. So that's predict 3. Just run it. Yeah, so here we can actually detect the whole backpack with a really high confidence score. We have a really nice prediction of the dog as well. We have something here, which is an error, but again, we get a pretty nice segmentation mask here of the dog with the X large model. But again, this is the largest model that they have, but really nice results, to be honest. We import the dataset. We just run this block of code, and then we can go down and train the model. It will basically just export the dataset to start with, and then we just specify the path to the dataset. So we will download the dataset over here to the left. Downloading dataset, unzipping it. We can see the cup segmentation over here to the left. We have a test set, train set, validation set. We can go in and see the images that we have. So here we see it. We can also see we have the labels. So we basically just have like these points here for our labels and also the classes. Let's just delete that. We'll go out here again. Now we can actually train the YOLO model. We set a task segment train mode. The small model. Let's just go for the let's actually go for let's go for the medium model. It was like some kind of like in between. We can also go for the large model. Image size will be, I think it was 640. I've trained it on. So let's just go in and verify that. We use the instant segmentation for our cop segmentation, and we have 640 by 640. So 640 by 640, 100 epochs might be too much. Let's just try it with 10 epochs to start with again, and then we can always like train for more epochs before we export it. So here we should be able, so we just run the large model just to get better accuracy when we're going to run it on our own computer. And then I'll just run the model here for 10 epochs. We get a summary of the model. So it's basically like this YOLOv8 model can both do segmentation, object detection, classification. But it was also the case for all the other versions of the YOLO models. So now we should be training. We can just follow the first couple of epochs. So this is pretty good practice. Just follow the first couple of epochs and make sure it does what it needs to do. And then you can always like increase the epochs and go away from the computer. So to have something about like the plotting here, so to have an error in the plotting, maybe it will be fixed in the near future, but it doesn't really matter for the training. So we'll get some errors, but it is inside like the plotting for like the box labels and so on, so it doesn't really matter. I could actually get already like after one epoch, we still get really high accuracy actually. So this is really nice. We also have a better data set for the instant segmentation compared to the object detection that I have. Let's just run here and see how it works. So here you can see for all the instances, we already, like after 2 epochs, we have way better accuracy compared to the update detection. So maybe we could actually use this instance segmentation dataset for our update detector as well, but it doesn't really matter when I'm just showing you guys how to do it and setting it up. So we have the box loss. The box loss is increasing, like decreasing nicely. We have the segmentation loss. It is also going down like significantly from up here. We have the box loss also going down. Instances like the mean average precision, is pretty good as well. Also for this 50 to 95 in intervals of 5. And then we take the average of that. So there's actually like pretty crazy results. Like we already have like 100% accuracy on our segmentation, what the mean average precision. So we are able to detect the optics that we have in our data set. So this is really nice. We're also using the large model, so maybe we could use the medium and small model and still get a really good model that is accurate. Again, this is not really a hard data set. It's not really a hard problem that I'm trying to solve. I just want to show you the process of it, and then you can use it for your own projects and applications. Like most object detection, like just simple 2D object detection problems are fairly easy to solve, especially with these new really good models. And also like harder problems, you will just need to know like how we can fine tune the models, what models you need, what optimizer, the different kind of like learning rates and all those different things. But here we can see like it looks pretty good here for the first 10 epochs. I'm not really sure if we need to train it for more. We could do it, but I'm probably just going to download this and see how it works out. You can also see the mask here. Pretty nice results on the mask as well. So this is basically just for optics, and then we have the masks over here to the right. Let's see if the loss is decreasing. The box loss is still decreasing here, so we still get a better model by training it for longer. But again, we have the large model, still some really nice results. So now the model here is done training. We have all the cups. We have all like the results here, like the mean average precision of all these classes. So really nice. We have the segment train, so we can basically just run this, and we should be able to see the confusion matrix correctly. So again, this is really awesome results. So we're able to detect all the classes that we have in our image. We can show the results as well. So here we can basically just see the training results. So we're training for 10 epochs. We can just see the losses are decreasing. The positions, the mean average position, and so on are increasing. We can see that we are converged here around like 100% mean average position. And also probably converged here at 50 to 95. So let's try to run the validation here on the segmentation. We have run segment train weights. So we have the best weights here. We have the data set location for our validation. Should be able to run it, and then we can actually see the results. So we should get pretty good accuracy here on the validation. Again, we get that. We can see we get a bit lower loss here. So we get a bit lower accuracy on our validation set. That makes sense as well. We can run a prediction and then just visualize the results and see how it does with the instance segmentation. it's called predict 4. So I'll just go inside that. Predict 4, we visualize the results. So here we can see the segmentation mask. This is just really crazy segmentation of these cops or like mocks. Get a really nice really nice segmentation around these objects. So here we're just showing 3 examples. We can just go with 5 maybe. Just see a couple more. It doesn't hurt anyone. So we can also see the top view here. Get a really nice segmentation. Like these segmentation mask here is actually like better than my annotations. Way better than my annotations. So that's good to see. Let's just go in here and download the model. So we go inside our runs segment. Then we have our train. We have the weights here, so we only train it once. We have the best model. We're going to download that. So now we have downloaded the weight. Let me just verify that is actually the correct one. And then I think I called the other one. Let's just go out and see. We have the custom YOLO. So we have the cop detector. And then let's just call it cop instance. And I'll just throw it over here. And then we basically have our 2 PyTorch models now trained on a custom data set. We both have object detection and instance segmentation. And then we can go in here, basically just specify it, use the tracker. So I have the tracker set up here. Then we basically just need to specify the path to the model. So instead of just using like a standard model, we just specify it as an input argument or from like the Python file that I showed you in the last video, where we can basically just pass in the model that we want to run in inference with. We have this YOLOv8 model. We can use the pre-trained ones. We can use the custom trained, like the fine-tuned on our own data set. We basically just throw it in. You can find the code here on the YOLOv8 GitHub repository, or you can find it on mine when I upload the YouTube videos. I already have it about like how we can do live inference with the pre-trained models. But now we're actually training on our own data set. I'm going to show you how you can get your own data set if you don't have one. How we can train the custom object detector as we just did here in this live session. Do instance segmentation, the exact same things as I've just been doing here. I'm just going to boil it down to the most important things. I'll create YouTube videos about all of it. I'll also go through this tracker, and then I'm going to show you some results. So basically, when I just import these models, we're going to run inference. I'm going to do that in separate YouTube videos or in individual YouTube videos. So definitely follow through. Make sure to watch the videos when I upload them. So this was basically the groundwork behind my YouTube videos. Then I can set it up for more recording, create the YouTube videos, and then I'll upload it to you guys so you can watch the results and see the output from these live sessions. So this is basically my work progress or process behind the scenes when I'm actually creating the videos. So when I get a new idea, when there are new models out there, I basically just sit here for a day, go through the different kind of things. Right now, I'm just going to create these live streams where I basically just do the process in a live stream. I talk about how I do it. I can ask, I can answer questions to you guys. You guys can see how I work. You can sit along, code with me, learn a thing or two. Also, just see behind the scenes. So it is not always just go inside a Visual Studio Code, create a new file, then just write the code with no errors, and all those different kind of things. There's actually a lot behind the videos, and I also have to put in the time to actually learn these things. So it's not just like I'm seeing these models for the first time. I just hit record and then I upload the video, and then I'm just a god at doing things and making no mistakes and so on. So this is just to show you guys the work progress and the work process behind it, and also just to see how do we go from actually just getting out here, looking at the models. So I didn't really know how to get into to actually extract information from the last video I uploaded to YouTube. now I have an understanding of that. We can use it for tracking. We can store the things. We can do like custom things to the predictions inside of this Python script as well. Now we can actually do custom instance segmentation and object detection. So basically, I'm going to create videos about that. I'll upload to my YouTube. So definitely hit like the subscribe button, also the bell notification on the video. Make sure that you hit the bell notification and that you have notifications on your phone, so you'll actually be notified when I upload those videos. They will be up here in the upcoming days. So the next couple of days, make sure to watch them, play around with it yourself, throw it down in the comment section if you have some really nice things that we need to test out, or if you just get some great results. I also have this course, the YOLOv8 course, where we basically do the whole process as well, but with YOLOv8. You can do the exact same thing with YOLOv8. You just have to do the exact same things, but that is a really nice course. I show different kind of like ways of how you can deploy these models. So not just using these like whole like code structures here and like these code bases for actually like running the models, but how can you run it in OpenCV with ONNX, where you just write like a couple of lines yourself, import the model, get the predictions, and you process the predictions yourself. Both with OpenCV, PyTorch, ONNX, and all those different kind of things. I also talk about the theory behind the YOLO model. So that is a really great course with both so you get to know how does it actually work under the hood, how does the architecture look like, and then the main focus is on actually deploying these models. So this was a really nice live coding session. We've been through a lot. Already gained a ton of knowledge, and we got some really nice results here in just around an hour. So this is really nice. I'll create videos about that, and then I'll just see you in those videos, guys.